Did you survive the last podcast? Gosh, I hope so. Geez, that was long. Holy smokes. Almost 20 minutes. So, but think of all the information you got from that podcast. Think about it. The most important, valuable thing here is you got to remember you have to identify your A, B, H, and K. Look, your A value right here. That's your vertical stretch factor. Your B, well, surprisingly enough, there is no B value there. It's a 1. Your H value right here, don't forget, you have to subtract that. That's a -1, okay? So a -1 pops in there, just like before, just like the transformations before. Your K is a -2. So now start doing this. This, of course, means a movement of 1 to the left. That's 1 to the left, and you know and I know we're talking about, yes, there it is, the vertical asymptote. So why don't we just put that in right now? X equals to -1, okay? Horizontally, look at this. You're going down 2. So 1, 2, there's your horizontal. Beautiful, excellent, there it is. So you can write down there that your horizontal is y equals to -2. You can even do the domain and range at this point. You can even do the domain and range at this point, because check this out. If you figure out the non-permissible value here, x plus 1 cannot equal to 0 because that's the only portion that is in the denominator. Bringing that over, x cannot equal to -1. There you go. So your domain then is all values of x such that x cannot equal to -1, right? And x is an element of R. Remember, though, what's really, really important here is that the vertical asymptote is an equal sign. The non-permissible value stated in the domain is a not equal to sign. Very important, okay? Same thing goes with the horizontal asymptote. The horizontal asymptote is an equal sign. But when you're doing the range, you know, being that it's an asymptote, it gets close to that -2, but never touches. So all the values of y such that y cannot equal to -2 and y is an element of R. There you go. So now you got, look how much you've got done. It's incredible. Let's do our x-intercept, y-intercept now. X-intercept happens, oh, real simple. X-intercept happens when y equals to 0. So remember the formula that we were dealing with. Remember this guy way up here. We're dealing with 3 over x plus 1 minus 2. 3 over x plus 1 minus 2. That's what your y equals to. So figuring out x-intercept, y equals to 0. That's 0 equals to 3 over x plus 1 minus 2. Okay, let's keep on solving this. We're going to need lots of space because we're doing algebra here. Add 2 to both sides. Look at that. Cancels, leaving you 2 equals to 3 over x plus 1. Cross multiply, 2 times x plus 1 equals to 3. Divide by 2. Divide by 2. X plus 1 equals to 3 over 2. Subtract 1. Subtract 1. Oh my gotcha. That's a fraction. 3 over 2 subtract 1 over 1 is 3 over 2. Subtract 2 over 2, which equals, guess what? 1/2. There's your x-intercept at 1/2. Go back to your graph. X equals to 1/2 right there. Put it in here. X equals to 1/2. Beautiful. Okay, so now let's figure out the y-intercept. Y-intercept is super easy. Y-intercept, you know, happens when x equals to 0. Throw it in there. Let's go. X equals to 0. Write out the same formula again. Well, you did right here. So let's avoid some messiness. You know x is 0. So guess what? That leaves you with 3 over 1 minus 2. Okay? 3 over 1 is 3. 3 minus 2. Oh my goodness. Y equals to 1. Oh, that's so incredibly rough. Look, y equals to 1, which is right here. Oh my. So you got a point here and you got a point here. And look, you can even start drawing this side. Look, look. Beautiful. Right? Now, remember what we used before to help us draw. Okay? Oh, better put in my y-intercept equals to 1. Otherwise, I'd dock myself some points there. Now, remember what we used before. We used those wonderful points of 1, 1, okay? And -1, -1. to determine a little bit more accuracy. Well, since you've got 2 points already on this side, don't even bother. Let's go directly to this one. Let's go directly to this one. And reason why here is, look, A is 3, K is minus 2. So minus 1 times the stretch factor, 3, subtract 2. Minus 1 times 3 is 3, subtract 2. Oh, look at that. That's going to end up giving us minus 5. Okay, now what's the other point? All right, there's the B and H. Negative 1 times 1 is negative 1, plus a negative 1 for your H value gives us a minus 2. So your other point is at minus 2, 5, which is right here. And now look, you can fairly accurately draw that one as well. There's your graph. Okay, last thing we got to do, convert this polynomial into rational form, just like we did before. So basically, folks, all I'm doing by converting it to rational form here is just kind of putting this all together. What do I mean? Take a look. Your original polynomial that was given to you was this. This is kind of like in the horizontal asymptote, vertical asymptote form, right? Okay, so you don't want it in this form all the time. You got to remember, this is over 1. And what you learned last year, common denominators, right? Multiply this to get a common denominator. So that means this whole thing is over x plus 1. And check this out. This is the 3 right here. There's the minus 2 that you're going to distribute in, giving you minus 2x minus 2, combined like terms, bada-boop, bada-boop. 3 minus 2 is 1, minus 2x over x plus 1. That's what it looks like. Now, some people are asking me, they're going and saying, well, sir, teacher, how can I be sure that these are actually the right equations? You're telling me that this equation here, right, and this equation here are the same thing. Well, best thing in the world is throw it on your graphing calculator. Watch this. I'm going to put this one in here right now, okay? Do you remember? I'm going to use the alpha buttons. Remember the alpha buttons? Yeah, I'm going to choose numerator over denominator. There it is. That's 3 over x plus 1. Now, if you don't have that feature on your calculator, you might want to upgrade, okay? But if you don't have it either and you can't afford to upgrade, that's fine. Just remember that when you're dividing, you have to have brackets around things. So you would need a bracket around this whole thing here and here in order for it to work properly, okay? Now, I'm going to graph this thing. Bada boom. Does that all look an awful lot like what we had? You betcha it looks an awful lot like what we had. Now, let's put this new formula that we just figured out way back here, dun, da, 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 into the calculator, okay? There it is, 1 minus 2x, x plus 1. Throw it in your calculator. Go down here into y2. Now think about it. What's going to happen here is the original graph is in blue, okay? So if I show you the original graph, boom, there it is. But watch what happens when I put what we think is exactly the same graph now, just rearranged into y2. If it's perfect, it should change this entire blue graph into red. Watch this. This is cool. So I'm going to go alpha again. I'm going to take my numerator over denominator. I'm going to put my 1 minus 2x in there. And down here, I'm going to put in my x plus 1. Keep your fingers crossed. Let's see if this actually works. Ready? So the blue graph will turn red. Go. Look at that. It did. So you know, because it traced right over top, those are two different looking equations, but the graph is the same, telling you that both those equations are equal, and you did it right. Yes.